Hi, this is Dr. Joannides, Chief Medical Director at Optimum Re, and this is the Optimum Academy, Cholesterol 101, video number 4, Treatment of Elevated Cholesterol. So let's get started. So when we want to manage elevated non-HDL levels, or if we want to manage things like elevated LDL levels, statins are the first line therapy, followed by drugs like as I spelled out here, EZETIMIBE, which actually prevent cholesterol from entering the gut. And then there's other drugs that are often tried called PCSK9 inhibitors. So basically we have three different things which may be useful to us as we try to manage elevated cholesterol levels. So what is a statin? It's a small molecule, a synthetic compound that acts as a competitive inhibitor of a particular enzyme, so it inhibits cholesterol synthesis in the body. So statins block this synthesis and helps lower the cholesterol levels by preventing the production of cholesterol. It also has an effect, statins do, to increase the number of LDL receptors on the liver cells to help remove LDL from the blood. So we have these two mechanisms of action. They increase the number of LDL receptors available to bind and remove LDL from the system and lower LDL by 20 to 60%. And then it has the feature that I mentioned where it helps limit the production of cholesterol in the cells. And we have these different types of statins, which you've heard of and seen in APSs. Atorvastatin, Lipitor, which is the most prescribed. Then there's Zocor. Crestor is the most potent. And then the other types of statins are mentioned. So we need LDL receptors on the liver cells to help remove LDL from the blood. And what we want to do is have those LDL receptors, which kind of grab the LDL from the blood, move it into the liver cell, and then we want to recycle that LDL receptor. So that's the key ingredient, which statins help to do by recycling LDL receptors and removing more LDL from the blood. So statins are helpful in many ways. They help lower the non-HDL or LDL levels, which is a major contributor to risk. And they also, on the fourth bullet, they increase the levels of HDL or the good cholesterol. So people may benefit by both lowering the bad cholesterol, LDL levels, or non-HDL cholesterol, and it may increase the beneficial HDL levels. So what do statins actually do on lipids? They decrease LDL, they decrease non-HDL cholesterol, which is total cholesterol minus HDL. They decrease apolipoprotein B that we've talked about in prior videos on cholesterol 101. Their response on triglycerides are variable. They may boost HDL by a small amount, but they have no effect on lipoprotein little a in parentheses. And that's one of the problems that we have with trying to treat people that genetically have elevated lipoprotein little a levels. So statins are kind of like vitamin S. They have beneficial effects, and a substantial number of the population and substantial number of the insurance population benefit from the cholesterol lowering abilities of statins. And one or other beneficial effects are statins are also anti-inflammatory and can consistently decrease CRP levels, which is a marker for inflammation in the body. So these effects are called pleiotropic effects. And so in addition to lowering cholesterol, you can see all the other beneficial effects that statins provide. Decreased platelet activation, decreased thrombosis, decreased inflammation. So there's a lot going on from the benefits of statins, and a lot of the improvement in mortality in the book of business in many life insurance companies is that statins continue to give good results, people that are treated with statins, and that's a significant number. Possibly 35 to 40% of the insurance population is on a statin. So not only are you getting the beneficial cholesterol lowering effects, but also these other favorable qualities that statins provide. So the good mortality that we see in life insurance is riding on the shoulders of all the people that have taken statins for all the years that they've been available. One thing to remember is with certain statins, you should not take them with grapefruit juice because it actually interferes with the metabolism of the drugs, and there may be a higher level of the drugs causing a problem. So it's best just when you're taking your medications, don't take them with grapefruit juice, not just statins, but in order to avoid that with a lot of different medicines. For some reason, grapefruit juice has a negative effect on metabolism of certain drugs. This cholesterol absorption inhibitor that I mentioned is another way to treat elevated cholesterol levels, and it can be used with statins or with other drugs, and there's actually a combo fixed combination of a statin and this cholesterol absorption inhibitor to treat elevated cholesterol levels. So that you may see that on people's attending physician statements. And the third group of drugs that I wanted to mention are called PCSK9 inhibitors. And PCSK9, it's a lot of words there to describe something that's going on in the blood system. And I'll show you a picture of how these drugs particularly work. So the drug companies have created an injectable drug called PCSK9 inhibitors, which is a monoclonal antibody, and it's built on the same structure as a human immunoglobulin like IgG. And there's antigen binding sites on these PCSK9 inhibitor molecules that bind this PCSK9 that's in the blood. And I'll show you why this is important and why certain people require these drugs to help reduce the amount of LDL in their blood. So, to recycle or not to recycle, what is that all about? So, in order to continue to remove LDL from the blood, which is the bad cholesterol, you need an LDL receptor on the liver cell, which is to the left. But what happens is, if you have PCSK9 in the blood, it binds to the combination of the LDL and the LDL receptor, and it prevents recycling of the LDL receptor in the liver cell. But you want more recycling of LDL receptors because you want to remove more PCSK9 and LDL from the blood. So these PCSK9 inhibitors that I'm going to talk about in a minute, these drugs allow recycling of the LDL receptor because what they do is they act as a monoclonal antibody to bind the PCSK9 that's in the blood. So if you can see those purple curve things, which are tiny, but that's the PCSK9 in the blood. The green monoclonal antibody binds those so that the combination does not affect the LDL receptor and it can be recycled, and in the red circle, go back to the surface and take more LDL out of the system. So that's why PCSK9 are very valuable in certain people to help lower their LDL levels and put them in a better space. So they work by attaching at those binding sites any PCSK9 that's in the blood. And there's actually 2 of these monoclonal antibodies, and I'll show you what they look like. Some people can't take statins, so this would be an alternative, and it may be used in combination with statins as well. So 2 drugs are available. They're both monoclonal antibodies, Praluent and Repatha, and you're likely to see these in APSs, and they're both injectables to help lower LDL levels, and they work by inhibiting the PCSK9 in the blood so that more LDL receptors can recycle. And how did this come about? So these new drugs that are being used for cholesterol lowering, there was a new drug that was discovered, and I'll show you how that came to be. In the 1990s, horticulturists wanted to get a deeper purple petunia, of all things. And so they thought if they could inject deep purple color RNA to a purple petunia, they could make a petunia that's a darker purple color. But when they did it, what happened was they actually got white splotches in their flowers. So the opposite of what they were hoping for occurred. And what they found was that when they injected the RNA, it actually interfered with the RNA process, and so it was called small interfering, or little s, little I RNA, small interfering RNA. And that's why when you go to Home Depot or Lowe's and you see these pretty flowers that have, dark parts and white parts in the flower, those are actually produced by using interfering RNA, small interfering RNA in the flowers, and it works in humans to actually, as a drug that's been designed to lower cholesterol. And so it's called Leqvio, or inclisiran, and it's the only small interfering RNA drug in the United States, and it can also affect the PCSK9 and help with lowering cholesterol levels. So you may see that in APSs as well. So our 3 typical ways of treating elevated cholesterol levels are using statins, the absorption inhibitor, and the PCSK9 inhibitor. So we've got 3 alternatives to try to increase the number of LDL receptors and get the bad cholesterol out of the system. Now, hot off the press, May 2024, a new discovery has been made which may help treat lipoprotein A elevated levels, because none of the other 3 pathways that I just mentioned affect lipoprotein A levels. But this new drug, reported in Nature, and then there's a big trial going on called the Kraken trial, is a drug called muvalaplin, and it's an ongoing trial by Eli Lilly, and it apparently has shown lowering lipoprotein little a levels by up to 86% without side effects. So this is a big new advance, because nothing before affected genetically elevated lipoprotein A levels. So this would be a big step forward if we have an addition of a drug that can lower lipoprotein little a levels. And the way it works, it's called a Kringle blocker. And you'll remember the word Kringle from the prior Cholesterol 101 talks that you watched in these Cholesterol 101 videos. So when we talk about how it works, we have to know about bonds. And we've got James bonds, we've got Muni bonds, and the bonds we're interested in for this drug to work, we prevent what's called a disulfide bond. So it's like two sulfide molecules that bond together. So this is how this drug works. So this new drug lowers lipoprotein little a, because when you take it, it sits on a particular set of kringles called kringle 7 and kringle 8. By that drug sitting on those kringles, it prevents the disulfide bonds forming at kringle 9 between apoprotein little a and apo big B on the LDL particle, which makes up the entire thing is called lipoprotein little a. So that molecule is prevented from forming because the disulfide bond cannot form. So you basically have an LDL molecule without the apo little a, so you don't get a full development of lipoprotein little a. So by doing that, you can actually affect the genetically elevated levels of lipoprotein little a in certain people. So this is a new drug. We're keeping an eye on it to see if it will actually work. So that completes video 4 on treating cholesterol. And stay tuned for the last video in Cholesterol 101 series, video number 5.